Good afternoon, everyone. Thank you for joining this session of the HEA's Hydrogen Bytes series. As many of you are aware, the HEA is the largest trade association in the UK representing hydrogen. We represent a range of members right across the whole value chain, working in production, with low carbon hydrogen production and derivative production, transportation and storage, use applications from hydrogen to power to hydrogen in mobility, and also industrial use applications as well. And then the HEA is very much the voice of the hydrogen supply chain. So everything from materials, components and instrumentation to professional services and the academic sector as well. Today, the HEA is joined by one of our members, Otto Simon. It's really great to have you here today. Otto Simon is a process-led consultancy and project delivery organisation. And today we are joined here by Clive Mansfield, Hydrogen Portfolio and Project Manager, and his colleagues Andy Bailey and Adam Drop, if I pronounce that correctly, who are his team of process and commissioning engineers. So just a couple of housekeeping things. There will be about a 20-minute presentation from Otto Simon, and then there'll be an opportunity for 5 to 10 minutes of Q&A. There is a Q&A function in the webinar format, so if you can pop your questions in there as the presentation is occurring. And then there is also a chat function as well, so I will look across the Q&A and chat functions for any questions, but if you can, the Q&A question function is the best place to put your questions. So without further ado, I'll stop sharing my screen and pass over to Clive, Andy and Adam. So thank you very much.
Thank you. Right, that's all. Right, so fingers crossed. Great. You have our presentation in front of you now. So thank you. Good afternoon, everyone. Yeah, I want to talk a little bit today about some of the experiences that we've gained as a company and as individuals with projects with hydrogen. We're proud to say that we have moved molecules of hydrogen around in a variety of applications, and doing that we've learned quite a lot. So very quickly, who are we? As Olivia's just mentioned, we're engineers. We're based in South Manchester. There's about 40 of us. I've got 2 of my process engineering colleagues here, Andy and Adam. We also have process safety expertise, mechanical, electrical, control system expertise, and some project management skills. In 2019, we became an employee-owned trust, which means that each of us have an individual stake in the performance of the company, and hopefully makes a difference to how you feel when you walk in on a Monday morning. Our background, although we are just over 20 years old now as a company, our background is much, much older. It goes back 150 years into the Victorian era, and was centered pretty much totally on the coke and coal industry, mainly for the steel production. You need coke to make your steel. The byproduct is coke oven gas, which many of you will know is 50–60% hydrogen. So our history with hydrogen goes back a long way. Steel manufacturing in the UK has diminished significantly in recent years, and there are no coke ovens left in the UK. So we've had to diversify, And broadly, this slide is showing you the 4 areas that we've moved into. Hydrogen and decarbonisation being one, and that's my particular area of responsibility and what I want to talk to you today. As I said at the outset, we've done a number of projects with hydrogen. A few years ago, I'll start at the one on the bottom, HEA. Many of you might have heard of the HEA project that was undertaken at Keele University. We were the engineers for that project. We designed the compound, we integrated the electrolyzer and the gas grid entry unit. We worked with the consortium in developing that project. Adam here is sitting to my left, commissioning engineer. So it's a real live project with hydrogen injected into the grid at Keele University. On a more industrial setting, we've worked on a number of the so-called industrial fuel switching trials, relatively short-term trials to test whether manufacturers of various products can produce their product using hydrogen as a fuel. And I'll talk a little bit more about those later. But there's technologies as varied as float glass and breakfast cereals and aluminium recycling. I won't read this slide out because this is just an index essentially of what's coming up. Some of the various issues and problems that we've encountered and how we managed to find our way around them to make sure that those projects work. So, many challenges. And I've tried to put them into some sort of order. And so, to start off with, when you're designing a hydrogen facility, we have found that there's a host of different standards and regulations. Nothing specifically for hydrogen in a lot of applications, and a lot of suppliers, industries, etc., all have their own. And so it becomes quite a task right at the outset to define your regulatory, your standards environment. And so it is key that at the outset you define how you are going to, what environment you're going to use from a regulatory and a standard aspect. Write it down and share it with everybody who's involved in the project to make sure that everybody is aligned. Take a pragmatic approach to some of the regulations. Some of the regulations might be natural gas related and you're adjusting them for hydrogen. And so there can be a tendency sometimes to be a little bit over conservative. So be pragmatic, use a risk-based assessment, write it down, make sure that everyone's in agreement with what you're doing, and do this nice and early. Just as an example, this next slide, there you go, some pictures of the front pages of a whole host of standards that you have to navigate your way through. One of the things we sometimes do is just draw a picture. This is a project we're working on at the moment. You don't need to understand all the read all the various boxes, but there's a whole series of processing stages and just a color-coded drawing to say, right, standard X is applied here, standard Y applies there. We then have found hydrogen has particular characteristics, and it's quite a challenging environment. Any faults in your fabrication, hydrogen can find it. So there's a few pictures here. The one on the right I'll start with. We had a valve with some really looked minor flaws, but hydrogen finds that problem. So you do need to be very careful when you're fabricating equipment for a hydrogen service that you do it with the highest possible standards. The picture in the middle, we'll see this one again later actually. The picture in the middle is some hydrogen leak detecting tape. And that's quite useful for testing things as you go along. Picture on the left is a hydrogen pressure reduction skid that was fabricated on site. Now, I don't know how easy it is for people to see, but there's a whole host of covers placed over the openings of this thing. Building on site is difficult, and it's especially difficult with hydrogen. So a strong recommendation to anyone doing anything of this nature, as much as possible, build it in a nice, warm, dry fabrication shop. And as I say on the next slide, get it nice and clean. Try and remove any debris from the manufacturing process and stop water getting in. Take some extreme measures really to keep your equipment clean, because hydrogen will find the fault. The picture here is not untypical when you're, so here we were installing a hydrogen pipe, and you might be able to make it out the pipe. We're installing into a congested area with difficult access. So when you're designing for something like this, and we're often designing in existing facilities that, you know, we're not starting from scratch with the design, we're going into existing facilities. You've got to think about your design for that application. So the classic one is where to put your flange connection, or indeed whether to fully weld your delivery pipe work. Welding is expensive. Welding is time consuming. It's sometimes difficult. But you've got to weigh these things up during your design. Try not to leave too many problems for the guys at site when they come to install it. Pick your materials correctly. On some of these short-term projects that I mentioned, the trials, we've been perfectly fine having carbon steel. You might want to think about stainless steel or others for longer-term applications. So another key lesson, during the design, think about the construction of your facility with hydrogen. This is a little bit of a summary, really. Yes, don't stick build. Don't leave lots of work to do on site. Even the smallest bit of contamination can cause you problems. Test things for leaks as much as you can before you get to site, and try and test every possible leak source that you can think of. And there's a little diagram here where we had some problems where hydrogen was leaking through the impulse line of a regulator valve. So try and test all that before you get to site. It's much, much easier. When you do get to site, you are going to have to test things, of course, for leaks. You leak test a natural gas system. So in one sense, it's situation as before. But as I'm sure most people listening to me will have heard, hydrogen can leak and is very searching. So you have to test for leaks. We use a helium and nitrogen mix for the leak testing. Helium is expensive. That's why we mix it with nitrogen. That's our preferred method. There's a few numbers there. Set yourself some criteria that you're going to test to. Agree these with everyone involved beforehand, of course, and make sure that everyone's comfortable with that. And then ultimately, you will need to leak test it on hydrogen. Purging. As with leak testing, this is something you do with natural gas as much as you do with any other gas. But with hydrogen, its characteristics mean it's more likely to ignite. It has a much wider flammability range and it has a lower ignition energy requirement than natural gas. So purging becomes just that little bit more, I won't say important, but you've got to be a little bit more thorough with your purging. So there is guidance, and I've listed a few of the standards there. There is I'll move on. Sorry, frog in the throat. When you are purging, and we purge, obviously you purge into and you purge out of service, we treat it, it's a non-routine operation. It's got to be carefully planned. It's a very manual operation usually. So you want to test your procedures beforehand. We've used human factors assessment, where you get someone who's a little bit independent of what you're doing, who comes in and basically asks lots of awkward questions about your procedures to make sure that you've thought of every possibility. So well-developed procedures that have been tested, thought through, and then when you actually get to do the purging, make sure you've got the right people who know what they're doing, done it before, and have a set of criteria that you know you're aiming for. And when you've finished, write it all down, document your results. Important to know and to be able to demonstrate that you have purged this system correctly. And we're doing this one. Okay, so something else that we attend to during design, as many people will say, hydrogen leaks, natural gas leaks, and I'm sure many of us, I know I have been on to industrial sites, and you can smell the natural gas, but nitrogen has a tendency to leak more readily. So you have to design on the assumption that it will leak. And once you've made that assessment that it will leak, you've got to say to yourself, right, where might it go? What problems might it create? Do I need to install additional ventilation, for example? And there's a picture on the right there of an installation we created. I think that was for the breakfast cereal manufacturing site. And over a particular part of the installation where you can see there's lots of flanges, some instrumentation, some valves, there's lots of opportunities there for hydrogen to escape. So some temporary, in this case, additional ventilation. And you can see the hood at the center of the picture above the equipment, and then the ducting taking away any leaking hydrogen and outside of the building. that system, the ventilation, the additional ventilation, became part of the safety control system. So until that ventilation was on and shown to be on, we didn't start flowing hydrogen through that system. The other, there's a couple of pictures there, the two in the middle, showing some smoke tests. We're testing to see what the natural ventilation in the building was before we started, giving us an understanding of where any leaking hydrogen might go. Hydrogen, if it does leak, and I say we must assume that it will tend to rise. It can then accumulate in roof spaces, which is something we need to avoid. So there's all these things to think about when you're designing a new hydrogen facility, especially if you're in an older existing facility that might have natural gas in, but hydrogen will behave in a slightly different way. So you've got to spend a bit of time thinking about what could happen if the hydrogen escapes. We also install leak detection and fire detection equipment. If hydrogen is burning, it's sometimes difficult to see. So detection. On the right again, I've got those hydrogen leak detector tapes. It goes smudgy black in the presence of hydrogen. Simple but effective way of testing for leaks. A lot of sites will have fire detection systems installed already. You might need to integrate into those. You might need to expand what they've got. They might not actually detect the hydrogen. So again, nice and early in the design process, spend a bit of time investigating what the existing systems are and what you might need to do. But also, it sounds, do the simple things. Once you've got your system up and running, have a walk round and with a hydrogen gas sniffer, test yourselves for any potential leaks. And do that on a fairly regular basis. There are new technologies that are coming along, and we need to keep an eye on those as they arrive. So yeah, there's quite a bit to do to ensure that you're designing a safe, compliant system. I want to talk very briefly about blending, and I will concentrate on the project that I mentioned that we did at HEA University, where we blended hydrogen and natural gas. When we are doing this, whatever your application, there are a few things you've got to ensure that you do. Primarily, if you're blending hydrogen into a natural gas network, you've got to make sure that the supply is maintained. If you lost your hydrogen supply, for example, and you're feeding natural gas to a university complex, you can't turn off the natural gas supply while you work out what's wrong with your hydrogen supply. You've got to maintain supply throughout. You have to comply with the various gas quality requirements of that network, and you need to understand a bit about what's happening in that network. And I'll come on to the problems that we had, or the difficulties we had at HEA in a bit. But a lot of this is possibly going to drive you in the direction of having some quite complex control systems, safety integrated systems, which take a good bit of design, a good bit of verification, and independent checking that you've done the right thing. So blending is not something to be undertaken lightly, but do it properly and it works. So what did we do at Keele? The thing about Keele University is it's a campus university, it's a big university, it's got accommodation, it's got shops, it's got banks, it's got a sports hall with a swimming pool and a big boiler. So it kind of looks like a small town. And the project was to blend up to 20% by volume of hydrogen into that distribution network, with the objective being to demonstrate that at that kind of percentage, the downstream users, the boilers in the students' accommodation, the shops, etc., that they saw no impact on their usage. The trial lasted for about 18 months and was successful. The consortium that we worked for included the likes of Cadent and NGN. The electrolyzer that produced the hydrogen on site came from ITN, a name I'm sure many people will be familiar with. We had the health and safety executive from Buxton engaged with us. They were part of the testing team. We were obviously engaged with Keele University itself, and the project developer is a company by the name of Progressive Energy. So that was the background. What were we out to achieve? We want to achieve 20% by volume, but with a downstream demand that's completely variable, and we have no ability to affect what's coming from the downstream, what the demand is. How did we do it? We didn't start at 20%, we started at 2%, and we built it up slowly. And we allowed ourselves buffer volumes we designed a buffer tank for the hydrogen. There's a buffer volume in the natural gas network. But you do have to accept that because you've got no control over what's happening downstream, and our control valve can't work instantaneously, you do have to accept that there's some compromises to be made. But as I say, because you've got a complex set of requirements, you've got to have a very reliable control system with some flexibility built in. So that was a project that we're really proud of at Keele University, and we demonstrated successful blending of hydrogen and natural gas. 18 months. We were tripped up by the COVID pandemic, which did not make life easy, but we got there. So yeah, we've demonstrated that blending into a natural gas distribution network is a viable proposition. And that's
thanks, Claire. Just coming in here. Oh, perfect. We just are at time, and there is a couple of questions. So if people are able to stay for a couple more minutes, as we have a couple of questions, but just wanted to flag time. But thanks, Claire. I'll let you make a few final remarks. Sorry, Clive. Do you want to make any final remarks, because I did interrupt you?
No, I'm done.
Okay, great.
I think I covered everything.
Yeah, no, thank you very much, Clive. That was a really thorough presentation and full of pragmatism, that really showcased your expertise in real world experience, which is very much what we like to see at the HEA. So thank you very much, Clive. There is a question in the chat from Andrew Varga from Citru. He has asked, as you consider that hydrogen will leak, does this mean that, in your view, hydrogen can only be used in full industrial applications rather than, for instance, domestic, retail, or commercial applications where blended natural gas type applications could leak and cause some problems?
It's a good question. The fuel switching trials are all obviously industrial applications, and some of them quite large industrial applications, environments where there's already numerous hazardous materials and processes going on. So some of the engineering terminology and procedures that we follow are familiar to some of these people, and that's not necessarily the case in some of the other applications. But ultimately, I don't see there being a problem in going to something like shops, sports halls. Using the Kiel example, that was a little bit more domestic than someone making glass. But personally, certainly to start off with, the industrial applications, they're the big users, and until there's a lot of hydrogen around, I think that's where we're going to be starting.
Thanks, Clive. Thanks for those insights. We just have another question that's come through from John Barton at Loughborough University with a question that is as follows. If you are going round with a hydrogen sniffer, what kind of DSEAR region is that? Zone of negligible extent only or zone 2?
Now, this is why I've got these two young, knowledgeable people in the room with me.
Hi there, Adam Johnson, I'm a process engineer. The role of the hydrogen sniffer really for these trials was because we had so many flanges around the system, and that was part of the agreed risk assessment for that project that an operator would be going around fairly regularly sniffing for hydrogen, irrespective of the zoning, zone of negligible extent or zone 2 requirements. It was just to make sure that if we did detect any leaks, we caught it as soon as they happened and they were still relatively small. So we're looking in the range of ppm region. So if you were to equate that to a zoning requirement, it would be what the negligible extent would be. However, that would have to be assessed based on the application. If it was indoors, outdoors, the pressure, it might actually be zone 2. But the whole purpose of gas sniffing is mainly to detect leaks before they happen, based on the high risk, the number of flanges for those particular projects.
Thank you,
Alan. Thank you, Clive, and thanks for that clarification, Adam. We are at time, so I think we are going to have to finish there. But just to communicate the follow-up, so the HEA will share both the recording that will be uploaded on our Hydrogen Bytes page on our website and a copy in a PDF format of the slides, if Otto Simon are okay with that. And kind of they can provide me any kind of contact details as well, so that will all be in the follow-up email that you'll receive. But Clive, if you do want to pop in the chat, the email address where's best to reach out to, then just as another touch point. And thank you all for joining. It's been a really detailed session and extremely informative, I'm sure, for the members and also the wider network that's joined us today as well. So thank you again, Otto Simon, for preparing that presentation, and and sharing the contact details in the chat, and for you all joining today. So thank you very much, and we'll see you at the next Hydrogen Bytes. Thank you.
Just copy my email and telephone number for you.
Great. Thank you, Clive. Goodbye, everyone. Have a great rest of your day.